Given beta equals 38 degrees, b equals 4.7, and c equals 5.9, solve the triangle. So the first thing I need to do is I need to actually draw a triangle, right? So that I can kind of get an idea of what we're talking about. Well, I know that 38 is an acute triangle, or at least an acute angle. So I'm going to make this 38, which makes the side opposite 4.7. If I make this one 5.9, that means gamma is opposite of it. That makes this alpha and this A. So I notice I have a side, and an angle. So that's SSA. And what is the first thing we always do with SSAs? We have to find the altitude, or H. So H is going to equal to 5.9, the sine of the only angle we were given, which is 38. And when I do this on my calculator, I get approximately 3.6. So what does that tell me? Well, I need to talk about that in relationship to B and C. Well, if this is H and B is 4.7, well, B is going to be greater than H. So far, so good, right? Well, and how do I relate B to C? Well, B is less than C. So what does that tell me? Well, that tells me that I'm going to actually have two triangles. So what started out as a seemingly innocent problem has now, of course, exploded into something more. So let's start with what we know. That's always the best place to start. So I have the law of sines, which tells me that 4.7 divided by the sine of 38 equals 5.9 divided by the sine of gamma. So far, so good, right? Now I need to figure out how to get gamma by itself. So I'm going to do a cross multiply and set equal, and when I do that, I get the sine of gamma equals 5.9 sine 38 divided by 4.7. And then, as you recall, that means then that gamma is going to equal the inverse sine of 5.9 sine 38 divided by 4.7. And when I do that on my handy dandy little calculator, I get that gamma equals to 50.6 degrees. Now remember, we said there could be two triangles. So what is another possibility that gamma could be? Well, I know that in a triangle I can only have 180 degrees, so my other possibility for gamma would be to take 180 minus what I just obtained, which is 50.6, and so gamma could also be 129.4 degrees. So we have both of our possibilities. Well, how's that going to help us? Well, now I can solve alpha plus beta plus gamma to find my alphas for either one of these situations. So I'm going to go ahead and I'm going to call one side T1, so that's going to be for triangle 1, and then I'm going to have T2 for triangle 2. So for triangle 1, I would have alpha plus beta plus gamma equals 180. I still don't know alpha, but I know beta is 38, and for the first one, I'm going to use the first value of gamma that I came up with, which is 50.6. And so when I do that, I get that alpha equals 91.4 degrees. Okay, so there's another answer that we just obtained. So now what am I missing from the first triangle? Well, I've got all of the angles, but I still need that third side. So I'm going to take the original 4.7 divided by sine 38, and now I want to find the sine A, the side A, divided by the sine of the number I just got, which is 91.4. If I solve this for A, I'm going to get 4.7 sine 91.4 divided by the sine of 38. And when I crunch all that into my calculator, I get that A equals 7.6. So there we go. We found A for the first triangle. Now I need to find A for the second triangle as well as alpha. So what I want you to do is to make sure that you can do this. You're basically going to repeat what I just did for triangle 1 for triangle 2. So pause the video, come back, check your answers, and make sure that you get the right ones. When you added up all of the angles that you had and subtracted from 180, you should have got that alpha equals 12.6 degrees. The other thing is then when you apply the law of sines, you should have gotten that A equals 1.7. So now make sure when you're grouping these together that you group together the ones that are the same. So I'm going to put a little check mark by all the ones that go with one triangle in blue. So I've got this 50.6, and then I've got this first alpha and the first A. And then the other group that goes together, I'm going to put a green check mark by, just so that you can remember what belongs to which triangle.